Okay. Good afternoon, all. Let's start with our second session. Let me share my screen. Okay. Yes. Okay. So as per the question, do we have any Raspberry Pi simulators? So I have already searched a bit, but I have not found any of the particularly good simulator yet, as Thinkercad is. But I have managed to find one simulator which is working with the Azure. So I'm putting that Azure link in the chat. So Azure is a basically Amazon. Azure is a basically Microsoft Cloud. So on that cloud, they have created some script. So this is the link what I have posted. This is for the Raspberry Pi, and this is the GitHub link where that simulator code is. But I'm not sure whether this Raspberry Pi simulator is working in a different sensor environment. But I need to check it. So what I'll be doing is that today I'll be checking it, and once I'm satisfied with any of the simulator's performance, that link I'll be sharing on the WhatsApp. Even on the on the visual circuit also, they have Microsoft have inserted some visual designer for Raspberry Pi, so that link is already sent on a chat. So you may refer on these links, so you can have a good what we can say search on it. Secondly, I found one link. It is for IoT for SMSs, but it requires login to create a simulator, and I don't know why it is not taking my both the email IDs, Gmail and official one. But you can try it out. But I'll also find some good simulator, because Raspberry is a closed source development board, and we are not able to take its semantic out as compared to the other development boards. Other development boards are open source, so it is very easy in that case to create some simulator using that wire diagram or a PCB design, so we can have much room to play with its circuitry. But when it is a closed source, or it is what is it is not the open source, it is a closed source, it is a proprietary, then it is a very difficult to do. But still, if there are any, I'll find it out. So taking our simulator again, if we wanted to create some kind of a movable parts like a rover, or if we wanted to create a COVID assistant rover. So because of this COVID, IoT and the basic prototypes of the IoTs are coming up very frequently. So there was a trend to develop some rovers which are actually having some pre-coded program, so they can get the medicines from uh, health workers, and then that medicine will be delivered to COVID patient without having any kind of a touch, or without having any physical contact. So in that case, we can use some kind of a motors. So these motors can be vary. So in a simulator, we are having a BO motor. So BO is battery operated motor having a dual shaft. Dual shaft means what? These are the shafts. So you can see this is the first shaft and this is the another shaft. So these are the two shafts which is connected to the motor, and this is a 5 volt motor, requires at least a 5 volt to operate. So I have given a 9 volt battery, and I have connected its two ends. So rather connecting it like this, what I'll be doing, I'll show you this. So the polarization of the batteries are very important, but these kind of motors, which are the BO motors, these are multi-polarized motors. Means what? If you attach positive end of a battery to a positive end of a motor, and of course negative to negative, then that motor will rotate in a particular direction. So it can be on a forward direction, or it can be a reverse direction. It is totally depend upon how the gears in that motor, the plastic gears are there in these kind of a motors, or some motors, that's a stepper motor or heavy duty motors, are having metal gears. So in type of a gear, what type of a gear it is having, and the assembly and mounting of that gear, the rotation is defined. So maybe it is a forward rotation, or it can be a backward rotation. So if you connect positive to positive, negative to negative, then it will move on to a certain direction. Then if you wanted to reverse it, then you need to swap it. So similarly, I wanted to connect this positive end of my 9-volt battery, that is indicated in a red connector, and negative end to the positive 2Y BO motor. And if I give a power to it, means I need to start the simulation. Now you can see the shafts are moving at towards me, means towards the signal, and it is giving us a minus RPM. So it is what, it is a reverse direction, right? And now it is moving reversely, so it is a reverse direction. So if you wanted to check the direction again, so on the simulation, if you wanted to check the direction, then you need to see the readings over here. Like here it is showing minus 286 RPM. So it defines that you are having reverse rotation. So if you wanted to correct it, then I'll just delete this one. I'll take it out. I'll try to be more professional now. Then I'll take this one, come around, I'll attach this, and if I start moving it, it is giving me a positive RPM. It means what? It is a forward rotation. Now where we will be using it, as I said, we can use these kind of a motors, or stepper motor. Stepper motors are much controlled environment motor, or we can have metal motors to work with. So these kind of a motors we can put into rover or something. So the real-time application of that is, I'm having a rover now, so I'll just switch on my camera. One wheel is missing. Okay, one wheel of my rover is missing now. This is the rover. Now it is having a traction wheel. So I'm creating a prototype of this, which can be work in a field area. I'll be mounting a robotic arm over it, and then that robotic arm will be moving around, having connecting some object from one area, and putting it to the another one. So this is the prototype of it. And if you can see over here, I'm having a Bluetooth for controlling my rover. I'm having a 9-volt alkyne battery, as alkyne is having a good power capacity, means the current which is flowing, it is a good. If you use a normal 9-volt battery, it is also fine, but the experience with that is very bad with me, as in previous version of this rover, where I'm having smaller wheels. The wheel gauge is much broader here, so I was having a smaller wheels at that time. I was using a normal 9-volt battery, so I've connected 4 batteries to it, but though it is not getting a sufficient power, then we need to control all these motors. So this is the motor what I have connected. So this is the L shape, a single what we can shaft. So this is a single shaft motor. So that single shaft motor I have connected. For a purpose, I have not screwed this tire. So this is a L shape. You can get a single rod shape with a dual shaft, but here we required a single shaft only. And these are the plastic motors. So it is having their shaft, and under this motor there will be gears. So these gears also plastic gears. Now to control the movement of our rover, we need to use motor drivers, because these drivers, these motors are what? These motors are the direct connection motors, DC or the BO motors. These are the BO motors. It needs a battery to operate. If these are the DC motors, direct current motors, which are the metallic motors, then it has to provide a direct power to it. Means all motors will require direct power. So the power consumption, braking, movement, right to left, left to right, all these movements, whatever we are doing it through our mobile application, that needs to be controlled. So that will be controlled via motor driver. So I'm using a motor driver shield. So this motor driver shield is attached to Arduino Uno. So if you can see over here, under this, there is a Arduino Uno, and I have programmed Uno to control the entire structure of this. And then this Bluetooth is connected to the main circuit, that is on a motor driver shield. So power is coming through motor driver shield, and then it is RX and TX. The communication end is coming directly from the board, that is Uno. Why I have connected these RX TX to the directly Uno? Because this motor driver shield is not having any capacity to communicate, because this motor driver shield is for the larger or the heavy motors, but I have managed to put it here because I'll be placing a object like the robotic arm above this, and that also will be controlled by motor driver shield. And I need to give a power to this, so I'll be giving a power through 9 volt of a connection. So once I give a power, so unfortunately I cannot drive it right now, because one wheel is not attached properly. And here I'll be requiring one Android application where I'll be controlling that rover. So the single 9 volt alkyne battery is enough to power four 5 volt single shaft motors. It is carrying a weight of the entire rover. And yes, for the chassis, I have used that Paytm wala QR scan wala pad. Because I was lazy that time to print it on a 3D printer, so I have not printed it on a 3D printer. I just borrowed this, and this is actually functioning. What I'll be doing is I'll be completing my robotic arm today, so I can demonstrate that robotic arm to you on tomorrow or day after tomorrow's session. So it will be having movements which can be controlled remotely, or when we can record those movements to the robot, and then that robot will be doing their tasks autonomously. And it can be getting the things like you see in assembly line. So if you visit any assembly line, there are some robots. Those are picking up some material from one cart and placing it to the vehicle or something, or it is about the stitching or welding. Then that pattern is a recorded pattern, or that pattern is the same pattern always for every single chassis what is coming to on or coming on that particular shaft. Very sorry, I got disconnected because of the bad network at my side, and even lights are off, and I'm experiencing some power failure at my end. Okay, so that was about the BO motor. So you can have a BO motor, like you can have it in Thinkercad, but Thinkercad will not give us a proper simulation to create a simulated RC cars or rover like I have did. But okay, we can manage something like this. So another part is if we wanted to use any of the wireless technology to interface with our sensors, or to operate our sensor. Like for example, if we are having this PIR motion sensor, so if I'm putting up a relay, and that relay I wanted to control, and that relay will be switching on something and switch off something, not always a light, it can be anything, it can be a pump or something, like we discussed about agriculture. So in the agricultural field, we can see that we can develop a particular application where we will be using our soil moisture sensor. That soil moisture sensor will examine the moisture or the wet area or wetness in a sand and or in a soil. So once that sand or a soil is dried, it automatically triggers a current, and that particular current will lead to a relay to switch on. Once that current makes relay switch on, that relay will be switching on the pump, and then pump will pump the water from any water source and pour to the field. That way we can do. And once another soil sensor or a particular soil sensor placed on a particular area is examines the wetness in that particular area, then automatically it sends a signal to switch off the relay, and automatically relay will be switching off the pump, saying that yes, now it is okay, the surface is uh, what we can say watery enough to provide waters. But again, it needs to be tuned very well. Like if we are having a very big farm, then it needs to have at least 2 or 3 hours of water supply and all. So we can improvise in that, but this can be a good project idea to implement, and we can have this smart automation type of a water system. Even we can use different sensors for doing the same, like the capacitive soil sensor for testing out the other sensing activities. So nowadays there is a trend where we can have a remote controlled app, and that app is switching on or switching off our appliances, or we can control the things through that. So how we can achieve it? But before doing that, let's see some important facts about Node MCU. Now, when talking about the Node MCU, or that ESP8266, so the main fact is that how you are connecting that Node MCU with the connections. So there will be a two types of a connection. One is a active mode, and second is a passive mode. Now, rectifying this into a web kind of a language, it will be your access point mode, and another will be your client mode. Now, what is the access point mode? Let me take my Node MCU. Okay, access point mode means this is my Node MCU. Let me stop the screen share so you can see it properly. Okay, so this is my Node MCU. So if I want my sensors to get connected remotely to this Node MCU, so I'll be putting this Node MCU into a access point mode. So this will act as a router, but it is having a limitation. It can connect up to 5 devices, not the sensors actually, but the devices we are talking about here. So up to 5 devices, this Node MCU can get connected. Maybe your laptop or desktop or any other wireless device, you can connect with this, and we can have a capacitive or the captive portal where we can control our devices, or we can see information flowing on there, or we can collect something, or we can instruct something like we do in ThinkSpeak. So on the ThinkSpeak is also a cloud platform where we can get information through our sensor. So that also we will be seeing how to integrate ThinkSpeak with our sensors. But before that, we will be connecting our sensors through the main Node MCU, and we'll try to collect as much as information we can get. So this can be in a access point mode, and 5 devices can get connected to this Node MCU. Now another mode is what that is the client mode. It means what this Node MCU will not have a ability to provide a connection, but instead of it will connect to the existing access point. So in the case of we are having just a PIR sensor, and we wanted to sense the activity and we wanted to log it. So instead of a user get connected to the Node MCU, it's better that Node MCU will connect to the existing network so user can log its entries. So that also we can do. Similarly, the same access point mode or the client side mode is beneficial in this case when we are having CAM32, ESP CAM32. So in this case, ESP CAM32 will get connected to the access point mode, and then we can view the connections, and then we can have a portal where we can see the live recording from the camera. So that time this client mode is very beneficial. So, as far as these sensors are concerned, we left with the one practical, that is the temperature sensor. Yesterday, temperature sensor was not calibrated well, and my sensor library was not updated. So I'll show you how to update our sensor library in order to work with various sensors. So Adafruit is the industry, or the Adafruit is a company. Actually, it is not the industry; it is a company, so which manufactures a lot of sensors. So they have their own driver sets designed. So most of the, or we can say 80% sensors are designed by Adafruit, or later on they are adopted by PCB manufacturers to create these PCB sensor sheets. So if we are having, I'll just share my screen. So likewise, yesterday I was having a one error, which is showing that it is not possible to burn program on a Arduino because the library was missing. This one was the library, Dht Sensor Library. So there are two types of library updation. One is you can directly download the library source from a GitHub and you can manually insert it. Like I can go to the GitHub, I can download the source code like here. I'll extract it. Now, once you download any source code from GitHub, never miss to edit it. The edit its name. It is always having master at the end. So you need to remove that dash master every time, and then copy that library. Go to your system folder. Go to the program files, find out, not to the program files, yes, program files x86 or whatever the architecture of CPU you are having. Then go to Arduino, and here you need to go to libraries and you need to paste here. That I have already having a Adafruit library, so I'm not going to paste it again and rewriting it, but you need to paste it here. This is the one method. Or another method is, which is a more convenient method, is that you can go into a IDE, go to tools, get onto a sketch, go to sketch first, go to include library, click on manage libraries, and if you know the name of the library, you can just search over here. So firstly it will try to update all the libraries when it is getting a chance to update it. Once it is updated, you can have here, and I'll type just DHT. So once I type DHT, I need to have a Adafruit DHT library, not the other DHT libraries. So these are the other libraries which can work with temperature and humidity sensors, because DHT is not only a temperature and humidity sensor. There are lot of sensors available which are sensing our temperature, humidity, than other things on that. So as I'm having a DHT11 sensor, so I'll be looking at the DHT sensor library. So this is the DHT sensor library via Adafruit. So it is by Adafruit. So we need to install the version. It is, in my case, it is already installed, and this library can be work as a driver for DHT11 and DHT22 humidity and temperature sensor. And here if we can see, these are the versions. So if one of the version is not working properly, you can shift to the lower version and see if it is compatible with your driver, or which is compatible with your board. But it is always recommended that you should have at least a latest version. So as this is concerned, so this my file is already inserted. Then these are the two types where we can insert a library. Now here what it will do, it is going to scan my vicinity, and it is a close proximity sensor, so it is not going to scan for a very large area. It will scan a temperature in a nearby field. So maybe I'm having a hair dryer or the hair heater, that dryer which is giving a warm waves. So if I'm having that warm flare, then I can use that dryer to check the intensity of the uh, temperature sensor. But unfortunately, I'm not having it right now. So what we'll do is we'll leave it as it is, and we'll check what temperature I'm having in my room, or what is the humidity level and other things. So as this is a DHT11, we need to uncomment the first one, that is a DHT11, that we are using a DHT11. If I'm having DHT22 or 21, that time I supposed to uncomment this and comment it this one. I'll explain the code in a bit, so we can understand how the codes are working. So here also we'll have a 3 pin. One is a plus, second is out, and other is minus. Means plus means the voltage, so it will go to a volt. Now this DHT11 works from 3.3 volt to a 5 volt. So it is already written over here. So it can work 3.3 volt or 5 volt. But still, uh, you can experiment it. Sometime it is not working on the 5 volt, as it is setting that it is over voltage. It means that it is having a more power than it's required. Then you need to shift it to 3.3. It will not destroy your sensor, but if you are using it frequent and you're doing the same thing frequently, then it will definitely damage your sensor. So I'm just putting it to the 3.3 volt. Let's not damage this. And then my out means my signal cable. So I have defined DHT pin to, I think, 2, or yeah, DHT pin to 2. So I'll be putting it to the 2, and one will be ground. Yes. So I have already done with my connection. Let's burn this program to the board. Yes, it is showing that COM6 is not able to open because I have not selected it. So it is COM14 in my case. Then I'll burn this. Now it is uploading, and done uploading. Now we'll open up a serial monitor, and we'll wait for sensing. So yes, now it is showing humidity is 40%, temperature is 31.20 degrees and 88.16 Fahrenheit. Heat index is this. Let's verify it whether it is taking it accurately or not. How do we verify this? We can get to the Google, sorry, Google, and ask Google for temperature. It is showing 34 degrees outside, because Google is taking outside of my society, and here we are inside house. So inside it is 30 degrees. So it is quite good inside, right? It is taking up very good. So if we wanted to take like this, if we wanted to experiment with our sensor, and we wanted to get this information out on the cloud, then how we can do it? So we can interface our Node MCU with uh, the sensor. So before interfacing the sensor with the Node MCU, let's have a one trial with the Node MCU. We'll create a one uh, portal where we will be having two buttons on and off, and then we'll have two LEDs in, inserted with Node MCU. Once we click on the first button, it's supposed to turn on the first LED and then off the second LED. and we can play with that. Even the status of what we are getting, that status also we need to get. And for that, what we will be doing for this, we will be connecting our Node MCU on the station mode. It means what? It will connect to my access point. So here I'm having my access point called RX100 5G. Even I'm having RX100. So this is a normal router, and it is having a 5G connection on it. Yes, it is just a frequency what 5G is using. I'm not using any 5G or the 5G LTE kind of a technology, because it is not implemented in India yet. So I'll be not getting it. So let's try that out. For this, I'll be using a code supposed to be here. Even I'm having a DHT as well to connect with this. We can have, let me check whether I'm having a proper GST. Okay, fine. Fine. Yes, we are having a proper DHT11 temperature sensors code, which can be integrated with Node MCU. So here you can see I've included two header files. One is a Wi-Fi and another is a web server. Now, Wi-Fi is very important. Like it can open up ESP32's all CAM modules, and it can start communicating. Another one is a web server header file, ASP8266 web server. So once we attach web server header file, that means it is in a both connection, like the active and the passive. So yeah, I can make it connect to the existing access point. Means I'll be putting it into a station mode. Like here I'm putting it into a station mode. I'm giving the constant SSD as RX100. Like here, if you can see, this is one, and I'm giving a password to it. And then once the connection is successfully connected, I can get the result out if it is connected here on the COM port. Like I'm getting a humidity status here. Similarly, I can get the result of Node MCU, whether it is connected to the device or it is trying to connect with it, and whatever the state it is. And once it is connected, I'll be prompting with the IP address. What IP address does Node have? And then that once I browse that IP address, temperature and whatever the data this DHT11 is capturing, that will be displayed on a web server, or the web page, not on the server, on the web page. So that is the whole logic behind DHT11 temp 1. And for our web server access point, what we can do is, I have already created these code to save our time typing it. So here is our code. So here I have created a access point. So it means what? I'll be having a SSID Alcatech access point, and the password 1234567 8. You can see over here. Once any device is connected to it, it will get an IP address in this range. I need to browse to the local IP address, that is the default gateway or the local IP address. Then I'll be greeting with the our web page, so I can control my LEDs through it. Even with the LEDs, I can control almost anything. I can control my BO motor, even I can control my drone, I can control my rover, anything I can do. Just we need to add some more lines of a code over here. So let's try to do the access point mode. So for this, what I'll be doing is, it is very convenient to use breadboard if we are not using any soldering or the soldering technique to solder our LEDs. So I'm just putting it on a plain breadboard. So I'm just giving it a go. Give me a minute. I'll just finish it up quick. I'll just open up my camera so everyone can see it properly. Yeah, now I'm having my breadboard ready, stitched to it, and let's me find it out. The pins, it is D7 and D6. So yes, we are ready to go on that. I can place it accordingly. Yeah. So I'll be taking up two LEDs. So here are the 5 millimeters of the LEDs. Smaller end is a ground and the larger one is a signal. So my first LED I have configured on the pin number D7, that is a digital 7. So what I'll do is I'll give the D7 here and one ground. And another is D6 and again the ground. Okay, so the connection is done. As Node Mcu is having micro USB, so I need to change my cord, a micro USB cord, and it is a bit different. Once we burn our code into a Node MCU, we need to reset its power cycle. Will get effect properly. So once I powered it on, it is flashing up a light. If I reset it again, and if you can see, these two LEDs are blinked. It means that the connection to the LED is proper. I know that this is a very basic one, but we need to go through with this because if we done it correctly on the basics, then the other part, like we wanted to control the entire your weather station, or we wanted to control the our Arduino pilot, means the quad captor, then it is very easy in that case. So I need to select the appropriate board. So I have already added my ESP8266 board library, a board manager library. Now, there is a question again, how we can add different development boards to the IDE, the Arduino IDE, because most of the development boards are compatible with Arduino IDE and it has to be inserted into it because Arduino IDE is only shipped with pre-installed Arduino boards. So we need to install other boards. So how we can do it? We can go to the tools, then go to the board, and then here is the board manager. So we need to click on board manager, and here we need to search for the appropriate board type. So and in my case, this is a ESP8266 Node MCU. So I'll search for ESP8 266. So once I search for ESP8266, so here is a chipset. Now Node MCU is a development board and ESP8266 is a Wi-Fi chip what is on the Node MCU. So here it is, ESP8266 by ESP8266 community. So I have already installed it and it is updated one. And if you can see, boards include in this package. So these are the different development boards which are having ESP8266 by this manufacturer. And here we can see Node MCU version 1.0 and Node MCU version 0.9. Both are here having 12 module, and here it is having 12E module. So 12 and 12E is what it is rated with the chipset. Right. And if you are having the another board, like here I'm having another ESP, Like here, this is a ESP32. Now, why I required a ESP32? Now, what is the difference between ESP32 and ESP8266? These are the board differences. ESP32 is this chipset, the camera wala chipset. So this is the ESP32 chipset. So we need to install the ESP chipset board manager into Arduino to configure this one, because it is using that chip. So again, same procedure, board manager, call it for ESP32. Previously it was 8266, now this is ESP32, and install it. It is from Expresses IF systems. And the same is the manufacturer of that this chipset. So it is written over here, Expresses. So I can configure this. I need to update it, so I can click on update where it is having update, and I was not having updated definition. So you can see now the board definitions are getting downloaded. It is of a 49 MB. It will be quick. If we don't update our drivers and the outdated drivers are there, and my API is my IDE is continuously getting updated, then it will create some errors while uploading our code. It will take a minute only. And I've done downloading some files. We have to wait a bit, because until unless this finishes up, we cannot upload a code. And even this Expressify systems card is in our Node MCU, because I'm using a Lua Node MCU, so it is having the same chipset. If you can see over here, it is the same chipset. So automatically it will update the code for this also. If you are not updating the code again, if you are not updating a code and your base version, again it will make some problems, like your sensor is not properly calibrating, or your sensor is not taking up the data, or your sensor is taking up a data but board is not displaying it, or that board is not properly initiating the sensors. It is not giving a proper power, because everything is based on the drivers what that board is having. Yeah, I think it is finished and it is installing the tools. It will finish the bit. Yes, now it is installing the boards and done. Okay, fine. So here in this case, for our this demonstration, I'll be using ESP8266. Then I'll be selecting my Node MCU version 1. Maybe it is here. Now these are the list of different boards. Now once I select the board, now here you can see it have confirmed through IDE. Now I need to select port, that is COM4, and yeah, and I need to burn this. So now what it will do is it will create a one more access point, right? So it is very difficult to connect with two access point with a single Wi-Fi card. So I'll be borrowing the another access card, that is my USB LAN port. It is better that we can connect through that. Here if you can see, my port is getting connected and it is not uploading it, right? Count 4 is not getting connected properly, so I need to maybe my node MCU is damaged. I'll be taking another node MCU what I'm having. Yes, it is giving an error that is timed out because maybe this is not functioning. I will try to upload it on the another node MCU. Now it is taking. Now it is writing. So once you get a writing, it means that it is uploading your code. And if you are getting a continuous error that it is connecting but it is not getting connected or it is not getting writed, then it means what, your board is damaged. And the most likely reason of board damaging is giving extra power to it or pin breakouts. These can be the reasons. Maybe there will be a one of the reason. So I have already connected, so I'm disconnecting it to place it on my breadboard. Yes, so I have placed it properly. I'll just reconnect my these LEDs. Then I'll be having 6 and it will go to ground again. Okay. Now it is giving me a proper connection, and if I reset this and if I go to a serial monitor, I need to change my baud rate speed to 115200, and again I need to reset here. It will try to connect to my, okay, so here it is saying that HTTP server is started and it is already up. Now it is time to connect my USB. Now here there is a second USB connection, so I'll come taking up. Now here it is already connected as I have already tried it once. So Alcatech AP is already connected. So I need to navigate myself to 192.168.1.1, and here is the LED status. Is my screen visible to all? Yeah, it is. Okay, here it is. So if you can see, ESP8266 web server. Now the Alka Technology is my company name. It is my another company. I'm having three companies: Softech Data Securities, Alka Technologies, and other is Samartha Techno Services. So all the IoT and other prototyping we take care by Alka Technology and Samartha Techno Services. So here is the access point mode. The status of LED 1 is off, like the LED 1 is off. Status of LED 2 is also off. If I wanted to on it, yes, it gives a proper feedback and my LED is on. Then it is off. Right. And if I want, and if you can see the status, LED 1 is on now and LED 2 is on now. If I off the LED, the status is directly changing. So this is your small web server application where you are controlling any device. So in this case, this is what, this is a LED. So if I connect my motor to it, then again motor will be behaving like this. Or if I connect my other sensor, that also connecting to it. So definitely we'll check with the another sensor, that is a DHT sensor. Let's see how exactly this DHT sensor is behaving on this case. So here also I'll be having a DHT sensor where it is. Yeah, this is a DHT sensor, and the DHT pin is on pin number 8. So what I'll be doing is I'll be taking up a DHT sensor on the breadboard only. I'll be making the connection because I'm having these male headers with me. It is very convenient right now to do. So the plus one, this is the plus one, is the that will go to, I'll just disconnect first. It will go to 3.3 as Node MCU is having all 3.3 outs. It is not having any 5 volt out. So it is having almost four 3.3 outs. I'm having one of the 3.3 out here. So there is no pin left. I'm just removing my LEDs. I'll be putting 3.3 here. Then middle one is my data, which is D8, D6, D8, and then this ground. Okay. So finally the connection is over. Let's try to burn this. Oh, now here I have selected Arduino Uno on COM4. That's why it is throwing a error that compilation terminated, because you are including a Wi-Fi header and there is no compatible board for it. So I need to change my board to Node MCU 1.0 and then port COM4. And here it will be connecting in a, not on a access point mode. Previously it was access point mode where I have to connect my device. So at that time my laptop is getting connected to the Node MCU and then I'm receiving the feedback. Now here my Node MCU is going to connect with the existing network. So in this case, existing network is RX100 is the existing network. So on this SSID, it is going to connect. So for that, the character is the same. Only the thing is we are using Wi-Fi than the web server, but we are providing our SSID, and here we are writing a code to connect with it. Previously, we are writing a code to open up a access point. So here we are at a station mode or a client mode. We'll try to upload it. Now it is getting connected. Okay, I have connections on it, so that's why it is not getting connected. And yes, another troubleshooting would be if you are using a breadboard like this, and these breadboards are solderless breadboards, so it is having a continuous power flow. If I'm putting my node MCU with the power, so it is automatically taking all the leads to the power, or I can use breadboard extra power supply to do it. So if your connections are in place, maybe that time also it is not getting connected to the board. So maybe that was the issue with my first node MCU. I forgot to mention that troubleshooting point. So that this is a quick troubleshooting. So I've removed my DHT11 sensor, so everything went well. So again, I have to structure it. So it is 3.3. Here it is 3.3. Then the middle one is 8. And I put to the okay. It is not going deep inside. Okay, 8. And then finally this is a ground one. I'll be using a ground. Now let's see whether it is connected. I need to change the baud rate to 11522 and it is still trying to connect. I'll reset it. Don't worry about the characters which are showing. Again we need to reset it, or again what I'll do is I'll give a power again. Open up the port. COM4 is busy. There it is busy. Maybe it is connected. Sorry, it was the last session. Somewhat it is not connecting to the board. Let's see whether it is connecting now. Yes, it is connecting to the RX100 now. It is showing that connecting to RX100. Let's put our connection back. Once it is ready and connected, then we can able to see our screen. And just give power count. Still it is not getting connected. So another troubleshooting is I'll make this 5G and again I will upload this. Now these are the practical problems what I mean, you may face while working with the libraries and working with the development boards. So we need to keep trying it, because though we have tried this many times, maybe sometime it get fails, and it always fails when we wanted to display to someone and we are very eager to display something. Okay, now I've resetted it. Let's see. It is still going on, trying to connect. We'll wait a bit. So I think there is a problem with the encryption of my router. So instead of that, I'll give my hotspot. I'll configure my hotspot. Still it is not connecting. Try with the another Node MCU. The last try will do. Otherwise, we'll skip to the next practical or the next session. As this is getting connected, I think it will get connected. Oh, my mistake, my mistake. A big mistake I made. I forgot to change the password. Very sorry for that. It was not this. It is this password. Yeah, I got it now. I'm very sorry. Let me just wire it up. How silly I am. Okay. It is black for the positive. It will go to 3 volts. Then middle one is go to 8 uh, RX 8, and this one is ground. That's why I'm thinking why it is happening. It is taking up a SSD, but it is not getting connected to that SSD. Yeah, now it's supposed to work. It will work. Uh, uh, so, yeah, at that. Yeah, password is correct. Mm, that there was a loose connection from my end. Okay, and the power. That will go to 8. Yeah, it is RX 105G. I was trying to connect. Why? No, it's supposed to work this time. Otherwise, I'll leave it as it is and we'll take a break then. Ah, okay. Leave it as it is. We'll take a short tea break, and after that, we'll start with the new session. But till that, I'll figure it out. What happened with this sensor, or maybe this Node MCU, and I'll get back to you. We'll take a tea break for now. We'll meet exactly by 3:50.